How does polar stratospheric ozone differ from tropospheric ozone? Imagine a layer of Earth's atmosphere that acts like a giant shield, protecting us from harmful ultraviolet rays. That's the ozone layer, mainly found in the stratosphere, which is about 10 to 50 kilometers above the surface. Now, within this layer, especially over the poles, ozone behaves very differently than the ozone we find closer to the ground. Understanding these differences helps us see how climate and atmospheric phenomena are connected to the health of our planet. Ozone is a molecule made of 3 oxygen atoms. In the stratosphere, ozone forms when sunlight splits oxygen molecules into individual atoms, which then combine with other oxygen molecules to make ozone. This process is strongest near the equator, and the ozone gets transported toward the poles by atmospheric circulation. Over time, this movement causes higher ozone concentrations in mid and high latitudes, especially during certain seasons. But in polar regions, the story gets more interesting because of extreme cold and unique cloud formations. During the long polar winters, temperatures in the stratosphere can plummet for below freezing, sometimes reaching -60 degrees Celsius. These freezing conditions lead to the formation of polar stratospheric clouds, which are made of tiny ice crystals and other particles. These clouds are very important because they provide a surface for chemical reactions involving human-made chemicals like chlorofluorocarbons. These reactions convert stable chlorine compounds into reactive forms that can destroy ozone. When spring arrives and sunlight returns, these reactive chlorine molecules break apart ozone molecules rapidly, causing a big thinning of the ozone layer over Antarctica, known as the ozone hole. The Arctic experiences similar but less severe ozone depletion because its polar vortex is usually less stable and colder conditions are less extreme. Now, when we look at ozone closer to the Earth's surface in the troposphere, it's a different story. Tropospheric ozone is created by chemical reactions involving pollutants like nitrogen oxides and volatile organic compounds, which come from vehicles, factories, and other human activities. Sunlight helps these reactions happen faster. But in polar regions, especially during winter, there are fewer pollution sources and less sunlight, so tropospheric ozone levels are usually quite low. During spring and summer, some ozone can from when sunlight increases and pollutants are transported from lower latitudes, but overall, the levels remain much lower than in busy cities or industrial areas. The role of ozone in the polar stratosphere is vital because it shields living things from ultraviolet radiation. When the ozone layer thins during the ozone hole, more UV rays reach the surface, which can harm ecosystems, damage crops, and increase skin cancer risks. That's why international efforts like the Montreal Protocol, which limits the use of ozone-depleting chemicals, are so important. Meanwhile, tropospheric ozone in polar regions doesn't have such a big impact on health or climate, because its levels are generally low and short-lived. Scientists keep a close on ozone levels over the poles using satellites, balloons, and ground stations. Monitoring helps us understand how the ozone layer is recovering and how climate change might influence these processes. It also helps predict UV exposure risks and guides policies to protect our environment. So, in essence, polar stratospheric ozone acts like a fragile shield that can be damaged by human chemicals, leading to the ozone hole, while tropospheric ozone in the polar regions is a minor player, mainly influenced by natural conditions and occasional pollution transport. Both types of ozone show us how interconnected Earth's atmosphere is and why protecting the ozone layer is so essential for life on our planet.